Hello everybody, my name is Emilio Yultik, and today I'm going to present you my research project for the CA2 of the NCI cybersecurity course in machine learning. My project was malware image classification, and we implement a hybrid head to this project. This is our agenda, and first of all, let's start with the motivation. Nowadays, due to the digitalization that we've been experimented due the improve of the technology and how it's getting more and playing a better paper inside our reality, we've been like experimenting some malware increases in this time, and also due to that, the malware volume and sophistication continue to rise, and this lead us to economic impact of cybercrime around 10.5 trillion, which is a huge amount of money. Okay, so our dataset is a mailing that comes from Microsoft, and they have 25 families. There are grayscale images that are rendered from PI binaries. So we search from this mailing dataset, and we did it. These are like converted into the executables into a grayscale. So here we find like highly imbalanced class distributions because there are a lot of from 10 to 1000 per family. So there are a lot of imbalance here. So related work to this is, for example, Qui. He introduced a proposal in order to do like conventional like machine learning approaches of free forest, k-neighbor. He did the proposal to do a like convolutional network and give another view to this problem with the grayscale malware image. So he proposed the dynamic rebalancing and fixed input limitation. So after this, Yu and Wang come here with the weighted softmax to address class imbalance and solve this problem. They did this with the PGG based improvements. And then it comes Bensual, the one we received the inspiration because he's using Inception V3 and getting an accuracy of 99.24% in mailing. So what we did was a backbone interceptor with V3, a stealth feature structure by the Inception family, and we created a hybrid head with a gap, a batch normalization, a dropout, and an arc phase like classifier. We think the most important here was the dropout because we looked to the paper and they said like the dropout is the best solution to avoid the overfitting. We processed the image in grayscale. We did some normalization and raised the backbone. The margin of error loss was additive angular margin, encouraged larger interclass separation. The tune margin was mainly on 0.5 and a scale of 30 to 64, and pairs natural with normalized features and class weights. So the evaluation protocol was the following. We used the metrics of accuracy and micro F1, calibration, and class balance sampling or loss weighting as needed. So as you can see, this is our overall results. You can see we got an accuracy of 99.71%. In the macro F1, we got 99.25, and the macro P 99. As you can see, like the overall metrics are above 99. So here I lead you with the confusion matrix that we got. As you can see, it was almost precise. Like you can see barely like 95%, or almost everything is 100%. So this is the metrics that we got from the test, and well, we are gonna present the limitation for this project. First of all, it was a closed set. So if you pass unseen families to this model, you're gonna be mismatched because it's out of the scope of the training of this machine learning product. Well, the scalability we face that in order that add more families is gonna increase the training, and the maintenance and the cost for the project is gonna be like higher. So the future work is mainly to try to do more class incremental learning, and try to implement more dataset evaluation. So increase and try to do a better project. So summarizing, our contribution was like the hybrid head and the nearest link accuracy with strong minority of class performance. Thank you for watching. Hopefully you like it, and see you.